Proteins, chapter 5, page 64. If anyone is joining late, please help them out with the topic name or page numbers. So protein, it's a macronutrient, okay? It gives you energy. It's not the first choice of energy, but it does give you energy. 1 gram of protein can give you 4 grams of energy, okay? So the main functions of protein within a human body is growth, maintenance, and repair. Growth specifically for growing children, okay? Once you turn into adults, growth will happen to a certain extent, but maintenance and repair takes the dominance, okay? That's the main function of that would be the main domain of protein, okay? In an adult body, in a growing child's body, or in a teenage body, it's more about growth. And sometimes excess protein can be used as a source of energy as well, okay? And protein is the only macronutrient. How it is different from other macronutrient? It is the only macronutrient which has nitrogen, okay? It has a nitrogen atom. It is a nitrogen containing food. And 50% of protein is present in your muscle in a human body. 50% of protein can be found in muscle, 20% is found in your bones, and 10% is found in skin in form of collagen and elastin. And rest of the protein is present in other form of in your body, even in blood, okay? Serum protein level, plasma albumin level, okay? Serum albumin levels are found. So that's another complex of protein as well. So here you can see the chemical composition of protein. Okay, here it has an amino group. You can see here. Okay, N. The N stands for nitrogen. That's a nitrogen atom, and 2 hydrogen atoms. So this becomes an amino group. Okay, protein can have as many as carbon chain as possible. Okay, different number of carbon chain forms a different kind of amino acid. Okay, essential, non-essential amino acid. So proteins are made up of amino acid. Okay, and what is amino acid? This is an entire amino acid structure. Why we call it as an amino acid? Because it has an amino group. Okay, it's an acid because it has a carboxyl group. Okay, all the proteins are synthesized from amino acid molecules. There are 20 different amino acids which are used in protein synthesis to make protein within your own body. Okay, you eat protein, it breaks down into amino acid, and these broken pieces of amino acids, just understand, like imagine there is a building. Okay, there is a building has been demolished. The debris, the bricks are again used to create a new building. Okay, so the building which was there in the first place, that is the protein that you get from food. Okay, entire protein in your intestine, it gets demolished. Okay, the brick structures are the amino acids, and out of these brick structures, amino acids, broken amino acids, a completely new building, a completely new protein for other purposes within your body is made. There are thousands of different protein which are made in your body for different specific purposes. Okay, so that is what we call as amino acids. Amino acids are the building blocks of protein. You take in protein, it breaks down into amino acids. The amino acids will come together in different permutations and combinations and create some new other protein within your body. Okay, so there are 20 different amino acids required for protein synthesis. Out of these 20 different amino acids, the way how they for like more than 1 lakh protein structure can be made by these 20 basic amino acids. Okay, in different combinations and permutations, different complex protein structures can be made. More than 1 lakh protein complex structures can be made. Okay, and unlike carbohydrates and lipids, protein contain nitrogen, which we have discussed already. It has a carboxyl group, it has an amino group, it has an hydrogen atom, it has a carbon atom. So that becomes a amino acid structure. And out of this 20 different amino acids, 9 are essential amino acids, 11 are non-essential amino acids. But when you are an infant, okay, when you are being breastfed are different complexes. Sometimes it could be sulfates, some oxalates, okay, phosphorus, could be, any other complex structure, okay, any other mineral or vitamin can come and join in the side R chain, and it becomes a completely different amino acid, okay. So when you are an infant, uh, 10 essential amino acids are there, okay. Histidine is one of the amino acid which is essential when when a child is being breastfed. After the breastfeeding years are done, when the child moves on into toddler phase, preschool phase, histidine is no longer an essential amino acid. It becomes a non-essential amino acid. Okay, so that's the only amino acid which changes from essential to non-essential. Okay, so for an adult, for the use of adults, information for adults is that 9 essential amino acids and 11 non-essential amino acids. Okay. Properties of protein. They are amphoteric in nature, which means they can act as both acid and they can act as base as well. Acid base, I guess we all know the difference between that. Okay. Hydrogen atoms will make it acidic in nature. H atom, H plus. Okay. OH, okay, the hydroxyl group, that will make it basic in nature. So here we have seen in the previous, those who have the textbook, they can see on page number 64, the general structure of an amino acid. It has an hydroxyl group and hydrogen atom as well. So it can act as an acid and it can act as a base, both. Okay. And they also have electric charges. They can migrate into electric field as well. And for each protein, there is a pH at which the positive and negative charges will be equal. Protein will not move into an electric field because pH of the protein is called isoelectric point of the protein, where it is completely neutral. So it will not go into an electric field. That's the chemistry part of it. Solubility. So each protein has a definite and characteristic solubility in a solution of known salt concentration. Okay. And in a specific pH, you can the protein cannot completely dissolve. Okay. Albumins, for example, albumins are soluble in water. Albumins are a type of protein which are soluble in water. Okay. Globulins are soluble in sodium chloride solution, that is salt water. Okay. But most of the globulins are insoluble in water. Okay. So different forms of protein, they can dissolve. Protein can definitely dissolve, but they require different concentration of any solutes. Okay. Colloidal nature, they have large molecular weight, and because of which they will not allow anything to pass through them. Okay. And that is the reason why when there is a because of the colloidal nature of protein, okay, even if you pass a torch of light, okay, just imagine you take a glass of water and you beat eggs into it. Okay. You beat eggs properly and pour it into a glass of water. Take a torch and try to and just try to pass the light through this water which has beaten up eggs. What do you think? Will the light easily pass through the beaten up eggs? It will not. Okay. It will create a certain degree of opacity. Okay. Opacity will be created because of it. That is one of the reason why it's colloidal in nature. Okay. Because it has large sizes. Protein has really large sizes. And because of this property, even after metabolism, okay, amino acids also, when they form other form of protein, even if it is small complex structure of protein, they will not pass through the membrane. Normally, protein will not pass through cell membranes. But if at all you find a protein in urine, okay, what it means that protein has passed through the cell membrane of kidneys and now it is there in the urine. So something has been damaged in the kidneys. Kidneys cellular structure has been damaged. Okay, that's how you identify some nephrotic conditions. Okay, because proteins usually normally are not supposed to travel through cell membranes. Okay, if the proteins are in the kidney filtration system, they will be stuck in the kidney filtration system. They will not pass through the filter system and go out of the body through urination. That is not normal. But if at all you find protein in urine, which indicates some possible damage has took place in the kidney membranes. Okay. So these are the properties of protein. Coming to the classification of protein, simple protein, conjugated protein, derived protein. Okay, simple proteins are like your basics, albumins, globulins, globins, protamines. Okay, in your skin, collagen, elastin, keratin. Okay, these all are simple protein found all throughout your body. Okay. Then you have conjugated protein. Okay, if you remember, somebody has asked what is the R chain. Okay, so this is what forms an R chain. R is just an X, like XYZ. Anything can attach to the protein structure. If a nucleus is getting attached to into the protein structure, it is nucleoprotein. If glucose is getting attached to the protein structure, glycoprotein. Okay, mucoprotein. If a lipid part or a fat, okay, a type of fat is getting attached to the protein structure, lipoprotein. If phosphorus get attached, phosphoprotein. If a color pigment, okay, melanin or so, any pigment is getting attached, chromoprotein, okay, metalloprotein. Any metals like zinc, magnesium, okay, any metals are getting attached, okay, any minerals are getting attached or metals are getting attached like iron, etc. So that becomes metalloprotein. Okay, so these are conjugated proteins. Then we have derived protein. Okay, derived protein means they are not formed naturally. Okay, many protein structures, amino acids, and other elements come together and form this protein. That is derived protein. They don't occur naturally. Okay, they are not found naturally. Some chemical reaction has to take place for this protein to be produced. Okay, so primary and secondary. Conjugated protein, you have coagulated protein. For example, when any blood coagulation takes place, you get hurt, a bruise happens, you bleed. Okay, within few minutes a clot formation is formed. Okay, so for that clot formation to form, a lot of proteins which are there in the serum albumin are getting coagulated because a lot of blood clotting factors as a domino effect have started its chain reaction. Okay, so what you get at the end is coagulated protein. Then proteins, metaproteins, okay, peptides, polypeptides. These are different types of derived protein. Peptides and all are the basic structure of your muscle and skin. Okay, polypeptides, peptides, these are different forms of protein derived from some chemical reaction, which are used up. These peptides, polypeptides are used by your body for other functions as well. Okay, so this is the basic classification of proteins. Coming to nutritional classification, is it clear to all till here? So nutritional classification, complete proteins. Okay. Example, egg, milk. We call egg and milk as a complete food. Why? because they have all the 10 essential amino acids that is required by human body nutritionally. You have egg, you have milk, you are sorted. Okay, from the viewpoint of proteins, you are sorted. But the viewpoint of like you require all the essential amino acids. Amino acids are protein. From the protein viewpoint, you are sorted. But from the carbohydrates, minerals, vitamin viewpoint, milk and egg do lack other elements. Okay, they are not a great source of vitamin C or iron as such. Okay, so but from a proteins point of view, we call it a complete protein. Why? Because this just one source of food can give a human being all the essential amino acids required. Okay, so these are called complete proteins. Any protein source, food source that has all these 10, we know that 20 amino acids are there, out of which 9 are essential, 11 are non-essential. Okay, for humans. For babies, growing babies, there are 10 essentials, 10 non-essentials. Okay, but milk has histidine. Egg also has histidine. So because of the presence of histidine, we call it as 10 essential amino acids are present in egg and milk. So it's a complete source of protein. Partially incomplete protein. So these proteins lack one or more essential acids. Okay. The essential amino acids are the ones you cannot make in your own body. You have to source it from food. Okay. Since your body can't make it on its own, you are sourcing it from food. We call it essential. These amino acids are essential in your diet. You require them in your diet. Non-essential amino acids, your body can make it on your own. Okay, you don't require them exclusively from food sources. That is non-essential. Okay, so these proteins, partially complete, incomplete protein or complete protein, they have essential amino acids out of, for example, let's say 10 essential amino acids. Some of these sources may have 8, some may have 9, some may have 7, but one or more than one essential amino acid is missing. Okay, and they can still give you growth, moderate growth. Okay, like example, wheat and rice protein. But how can you make it a complete protein? Let's say casein or cysteine or sorry, rice has cysteine, but dal does not have cysteine. Okay, cysteine is a protein that is present in rice. Okay, but dal does not have cysteine. But dal has other proteins like leucine or something like that, which is absent in rice. Okay, so when you combine rice and dal, what happens is that they are compensating each other for what they are lacking. Okay, what rice doesn't have, dal can give it. What dal does not have, rice can give it when you have rice and dal together. Okay, so these are incomplete proteins. They have all the other essential amino acids, but few of them are missing. One or more than one essential amino acids are missing. Okay, then incomplete proteins. Okay, at least 5 or 6 essential amino acids are missing. They don't promote growth. Okay, for example, gelatin and zein. Okay, gelatin is used for jelly making. When you make this sweet called jelly, okay, gelatin is used. In all the different forms of milk. Okay, all the different forms of milk is a complete source of protein. It could be cow milk, buffalo milk. Okay, buffalo milk is more rich in fat. Okay, fat concentration is high in buffalo milk. Yeah, rice and dal will provide you all the essential amino acids. But there is a drawback. 100 gram of dal chawal and 100 gram of eggs. Okay, which will give you more gram of protein? Is it 100 grams of rice and dal or 100 gram of eggs? Eggs. Both have all essential amino acids. Chemically speaking, they have all essential amino acids. Okay, but you want to fulfill, okay, I want 15 grams of protein in this meal itself. Okay, Having 100 gram of rice and dal will not fulfill that, but you're getting a lot of carbohydrates. You don't get much carbohydrates in egg. No carbohydrates is there in eggs. Okay. But there is a whole, when you eat rice and dal, you say it's a good source of protein. It's not the best source of protein. Protein is present there. All the essential amino acids are present in rice and dal. Okay. But you have to see how much carbohydrates rice and dal is giving you as well. You can't overlook that. Just for the sake of protein, your carbohydrate intake is also increasing. Okay. No, vegetarians have much other better options as well. Rice and dal chawal is just an example that I gave you. Okay. All the sources, best sources of protein, we will discuss later at the end of this class. Nutritional classification of amino acid. Essential or indispensable amino acid can't be synthesized in your body. You have to take them in your diet. Okay. And all these are essential amino acids: valine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan. Okay. These all are essential amino acids. Your body cannot produce them on its own. You have to depend on a food source to get these essential amino acids. Semi-essential amino acids. Okay. These are growth promoters. Okay. And they are not synthesized in the body in adequate amount, like arginine and histidine. As I mentioned, histidine is not synthesized in an infant's body. Okay. So through breast milk and other sorts of milk, the infant is getting histidine. Okay. But as soon as you grow up, you come out of the infancy, your body can produce histidine on its own. Okay. Arginine again is produced in the body, but again, it's not as adequate as how the body requires. Your body can synthesize it, but it's not enough. Okay. Then non-essential amino acids that are dispensable amino acids can be synthesized in the body, may not be a component of diet at all. Okay, like glycine, alanine, serine, cysteine, asparagine, glutamine, tyrosine, proline. Okay, these are non-essential amino acids. You don't require them from diet. If it is there in your diet. Okay, like cysteine, as I have given an example. Dal does not have cysteine, rice has cysteine, but cysteine is a non-essential amino acid. Okay, your body can produce cysteine on its own. Your hair, your skin, okay, it all has cysteine as a protein. Okay, glutamine as well. Your body can produce glutamine on its own. Okay, and you can supplement glutamine through diet as well. If it is there in the diet, whatever food you're having, it is there. It will not cause any harm. Okay. Coming to the functions of amino acids. The first main function of your protein is growth and new maintenance of tissue, new growth, building muscles. Okay. These can take place only when a specific mixture of amino acid is available, like whey protein, leucine, okay, casein. Casein and leucine is required for your muscle growth. Okay. And also the process of cell division, because when your cells are dividing, the person is growing. Okay. And even when the cell division is taking place, old cells are shed, new cells, because of cell division, new cells will replace the old cells. So maintenance is taking place. Okay. So for all these functions, specific proteins are required. And 1/6 of your wet cell mass is a protein. Okay, so that much protein is required in your regular diet. Even your framework within your bones, within your teeth, okay, protein molecules make up your framework. Collagen, which is present in your skin, your tendons, your ligaments, okay, these are the intercellular material that keeps these are like pillars. Okay, collagen is like a pillar that keeps your skin taut. Okay, and if you start losing collagen, just imagine pillars are breaking and the structure falls inside. That's how you get wrinkles and all. Okay. So for growth and maintenance, protein is required. Formation of essential body compounds, like if many hormones like insulin, gastrin, growth hormone, okay, enzymes, okay, these all are produced because of protein. Epinephrine is a hormone secreted by your adrenaline gland. Hemoglobin, the production of hemoglobin. Heme is iron, globin is protein. Okay, so production of hemoglobin, protein is required. So for all this formation of essential body compounds, protein is required. Transportation of nutrients, lipoprotein. That's the best example. Lipoprotein, okay? A protein that can carry fat molecules, okay, from point A to point B. What happens when your body does not have enough lipoprotein? Okay, the fat molecules will get stuck in certain parts of your artery, and that will give rise to cardiovascular diseases, atherosclerosis, heart attacks, coronary artery diseases. Why? Because you're not having enough amount of lipoprotein. Why you don't have enough amount of lipoprotein? Your diet is protein deficient. Okay, so those who are those who have a protein deficient diet, they also put themselves at a higher risk of developing cardiovascular diseases, because their body is not able to produce lipoprotein, which is supposed to move fat, okay, move fat molecules from point A to point B. Okay, if there is no movement of fat molecules, they get stuck, specifically LDL, okay, cholesterol, they get stuck, they will not move, and wherever they get stuck, they sit there. More molecules will come, obstruct, and form blockages in arteries. Okay. Regulation of water balance, as I mentioned, they act as both base and acid. So whenever the pH is like imbalanced, protein can come into play. Okay, they control the extracellular and intracellular compartments. They can hold water within themselves. Okay, when protein is present within a cell, it can hold water, it can catch on to water. Okay, so because of this, the hold that protein has on water, water imbalance in intracellular and extracellular matrix will not take place. Maintenance of pH, as I mentioned, the acidosis and alkalosis both can cause death. And proteins, they are buffers. They can act as acid, they can act as base. Whenever the blood is turning alkaline, the protein becomes acidic. The protein will lose its carboxyl group and it will become acidic in nature, and it can bring back the blood to its normal pH. When the blood is getting acidic, it will lose the hydrogen atoms, it will gain more on carboxyl atom, and it will make the blood basic in nature. Defense and detoxification, the body's ability to fight infection. Protein is required for your immune system to produce antibodies. Antibodies are made up of protein. Okay, so antibodies help in defense and detoxifying your entire body. And toxins present in the food, they are also detoxified using enzymes. And how enzymes are produced? Enzymes are produced because of amino acids that you get from protein. Source of energy, that is the last priority. Usually, protein can give you 4 kilocalories of energy, okay, just like carbohydrates. But only when carbohydrates are absent, fat is absent, only then the body will go to protein for energy requirement. So these are the functions of protein. Is it clear to all? Coming to the digestion and absorption of protein, Some specific function of amino acids are given, but that is not important. You don't have to mug up those things. Okay. Different amino acids have been mentioned, and what are their specific function is also mentioned. No need to mug up that. Just know the certain names of amino acids. That is more than enough. Specifically, if you know the names of essential amino acids, that is more than enough. Okay. So in your mouth, no digestion of protein can take place. In your mouth, you have saliva. Saliva has salivary amylase. Okay. No digestion takes place. Protein will not provide energy because for energy, the first option is carbohydrates. Second option is fat. Okay. Protein will be used up for other biochemical reactions within your body to build muscle, to build other blocks of your cells. Okay. And when you are starving yourself, that's when protein will be used up. That means your body will use its own protein. Muscles will be broken up for energy. So gastric digestion takes place. Okay, in your stomach, proteins. The first step of protein metabolism and digestion takes place in your stomach, not in your mouth. Salivary amylase, the enzyme present in saliva, has no effect on protein. But as soon as the protein-based food reaches your stomach, because of the acid in the stomach, hydrochloric acid, denaturation of your protein starts. Okay. And also the enzyme that is present in your gastric juice called pepsin. Because of hydrochloric acid and pepsin, the dietary protein will undergo denaturation and it gets partially hydrolyzed. Hydrolyzed means what? Protein, we have seen protein has hydrogen atoms. Hydrolyzed means these hydrogen atoms will be removed. Okay, that is hydrolysis, cut off the hydrogen atoms. Okay, so half digestion is done in stomach. And then from your pancreas, protease enzyme will be released, and this enzyme will get mixed up with the food that is coming out of the stomach in the duodenum. This will get mixed up, and from the duodenum onwards, the second step of digestion of protein will start because of the presence of protease. From the name itself, you can understand protease. It's an enzyme that breaks down protein. Okay, and in the intestine, big chunks of protein, denatured and partially hydrolyzed protein, will become completely hydrolyzed. They become small peptides, small amino acids. And because of these small structures that are left behind, the small structure can be actively absorbed by your intestine. Okay, amino acids will directly actively get absorbed inside the intestine, and from the intestine it will get into the bloodstream, and blood will take these amino acids wherever it is required to build up more protein within the body or for other production of hormones, enzymes, or other relative functions. Okay, so gastric digestion takes place because of hydrochloric acid and pepsin present in your stomach. Proteolysis in intestine takes place because of the protease secreted by pancreas. Absorption of amino acids inside your intestine takes place because they have become small peptides. They have become into small amino acids. And with the help of sodium, okay, this amino acid, once when they're getting absorbed, when sodium ion is present, which means salt, when salt is present, okay, because of the interaction between sodium ion and protein, direct active absorption takes place. Okay, which means salt helps in the absorption of protein into the intestine. Then digestibility of protein, it varies from food to food. Okay, when you heat milk over and over again, what do you think what happens to the quality of protein? It reduces. Okay, it gets denatured because when you expose protein to heat, okay, it coagulates. That is the reason why whenever you have any clothes that are blood stained, okay, blood stained clothes should not be washed in hot water. You have to first remove the stain using cold water. Okay, and once the stain is removed, only then, after applying soap and everything, you can wash the blood stained clothes in hot water. Otherwise, as soon as you expose the blood has serum albumin. Okay, blood has proteins in them. If you expose the blood stained clothes directly to warm water or hot water, the stain removal will be very difficult. Okay, because it will get coagulated and it will stick into the cloth fabric. Okay, so heat, over processing the food, overheating the food, it will denature your protein, it will coagulate your protein. The quality of the protein decreases when the cooking process increases. Okay, if you are getting acid reflux because of protein based diet, there are high chances that there are high amount of fat also which is present in the protein source that you have took. Okay, for example, if you take any meat is a good source of protein. Okay, non-vegetarian food is a good source of protein, but along with that, it has high amount of fat as well. Okay, but instead of meat, if you have 100 gram of meat and if you have 100 gram of sprouts, let's say, for example, green gram sprouts, moong sprouts, okay, germinated moong dal, okay, you will not suffer acid reflux there because there is absolutely like close to zero fats present in. Some fat is present, but it is healthy ones, but close to zero fats are present in moong sprouts. Okay, if a person is taking only veggies and they're suffering from acid reflux, reduce the spice. Reduce the spice, reduce the water content in the food, okay? And get an enteroscopy done because the sphincter, there are sphincters that control these are open, they control the opening and closing of your esophagus, okay? How the esophagus has to open into the stomach, how it has to close into the stomach. If the sphincter has undergone any trauma, definitely you will suffer from acid reflux, whatever food you take, okay? And even with vegetables, you're having acid reflux means you have to reduce or tone down the spices that you are using, tone down the water content that you are using. So metabolism, protein will break down into free amino acids, building blocks, and 20% of them undergoes oxidation and 80% of them is synthesized back into your intestine. It is synthesized back into forming other forms of protein within the body. That is the basic principle of your protein metabolism. Protein will be broken down to amino acids. Amino acids will be again synthesized and they will form back into some other form of protein. Amino acids that enter your liver, 20% of them are used to make enzymes, plasma protein, other nitrogen containing compounds like glutathione, carnitine, creatine, choline, etc. Some of the amino acids will stay back in the liver. 6% is released back into the plasma. And majority of the protein, 57% of amino acids is taken up by your liver and they get catabolized in the liver. Catabolized means they get used up in the liver. Sprouts you can have on a daily basis, but you have to check the oxalate rate in that as well. Having sprouts on a daily basis is good, but don't have the same form of sprouts. Like if it is green gram, don't have just green gram every day. Go to black chana, go to other forms of legumes, okay? Cowpeas, uh, other forms of legumes you can use, okay? Change the legumes and seeds that you use on a daily basis. Coming to the factors affecting protein utilization. Amino acid balance. Oxalates are like, it's like a precipitate which do not allow which do not allow the absorption and digestion of other nutrients as well. Okay, oxalates, phytates, they are present in so many plant sources. Okay, you can get rid of them by soaking the legumes in water. Okay, dry fruits and all you don't have to soak. You can have dry fruits and nuts as it is, seeds as well as it is, you can have, no worries. But when you are dealing with pulses and legumes, it's always better to soak them properly and then use it. Okay. So amino acid balance. Any excess of one amino acid in certain circumstances will reduce your total nutritive value. Okay. So a protein that may have an amino acid pattern that meets the need of one age group. Okay. While the same amino acid is not required in another age group, automatically your body will limit its absorption. Okay. For example, in infants, histidine is required, so maximum amount number of histidine will be absorbed by the food, by the milk. But as soon as the infant is growing into an adult, okay, into a child and then into a teenager, slowly the body will not absorb as much as histidine as required, because the absorption, the amino acid balance completely depends on what the body requires. Okay, what is the human body requires. Almonds and walnuts, you don't have to soak them. Okay, without soaking, even if you have raw almonds and walnut as it is, it will not cause any disbalance. But pulses and legumes, you have to soak. The pulses are seeds basically. Okay, pulses are edible seed, and legumes are like pea. Okay, you can imagine pea, you have to open the pea pod and then you get the peas from that. Okay. Legumes are more fresh in nature. Pulses are the dried ones. And usually pulses are seeds. Okay. Some studies have shown that when you soak the almonds, the phytate level and oxalate level increases. Okay. You can have it with the skin as well. It's a good source of fiber. Almond skin is a good source of fiber. Okay. If fiber is not is if it is not your like, if you want the mineral part of almonds, if you want the fat part of almond, you can remove the skin. Okay. But if you want to aid in the fiber content in your diet, have the almond with skin. It completely depends on how, what are your goals with almonds. Okay. Having almonds with skin, it will not allow the complete absorption of almond fat. Okay. It can prevent the almond fat absorption, but it can aid in its vitamin and mineral absorption. So it depends on what your personal goals are with almonds. So that is amino acid balance. As soon as your body is changing, body's needs are changing, your body knows how to pick up which type of amino acid from the food. Then calorie intake. When your calorie intake drops, Okay, when you starve yourself to a certain critical point, protein will be taken away from your own body, from muscle protein, bone protein, wherever protein are present within your body, that protein will be taken away. That will be used as a source of energy. Okay. And then immobility. People who don't move a lot, okay, sedentary lifestyle, don't know physical activity, no much movement in their life, okay, they tend to lose protein. Okay, bedridden people, people who are comatose, bedridden, okay, so they tend to lose protein from their body. And also during any injury, even if it is surgery, the incision is made purposely, right? Surgery, you make a purposeful wound, you make a purposeful incision, even if it is a surgery, wherever there is a wound, wherever there is a injury, nitrogen loss will be there from that affected area. Burns as well. When you have burned yourself, skin has burnt, any degree of burns, okay, as long as the wound is open, as long as the scar has not been formed, okay, nitrogen loss will take place from that wound area, injured area. Okay, and once the healing begins, once you start healing, the nitrogen losses, whatever nitrogen you have lost, with a good protein rich diet, you can replace all the losses. Then emotional stability, when you are stressed a lot, like when you are afraid, fearful, you suffer from anxiety, anger issues, okay, that can cause a series of changes in your body that can result in loss of nitrogen. So you lose a lot of protein, okay, when you are emotionally unstable. And it is seen that students who are appearing for exams, they lose a lot of nitrogen because of exam related stress. Also, when you're suffering from some severe pain, in terms like if there is anyone who's a cancer patient, okay, you undergo tremendous amount of pain, so that in that case also you lose a lot of protein from your body in form of nitrogen loss. People who work in night shifts, their circadian rhythm is out of whack. Okay, 2 days night shift, 5 days day shift, again evening shift, afternoon shift. People who work in shift usually, okay, they also undergo a lot of sleep related stress. Their nitrogen is also lost, their protein is also lost. Jet lag as well, when you are traveling to a different time zone, you undergo jet lag. Okay, in that situation also, you tend to lose a lot of protein and amino acids. Now coming to the quality of protein, there will be a lot of formula in this topic. So the formulas you don't have to by heart. Okay, some of the concepts of the formula I'll explain, but just understand the concepts of the formula. That's more than enough. You don't have to by heart. Okay. Even though if any questions regarding the formulas, if it comes, the exam is going to be an open textbook exam. Okay, so you can directly come to this chapter, check the formula, and you can answer the MCQs. But no need to by heart any of the formula. Okay. So quality of protein. How did we come to know that eggs are a complete protein, milk is a complete protein, vegetables are incomplete protein, wheat and rice, urad dal, okay, legumes, pulses, they are partially complete protein. How did we come to know? Okay, how did we categorize? How did we categorize these different food sources into good, bad, okay, and best source, a good source, bad source, okay? So this is true because of a series of formulas that were used in a laboratory. That's the reason why I'm telling you all these formulas are used in a nutritional laboratory, in a laboratory settings, where they have equipments to measure exactly. Okay, uh, in your day-to-day life you don't require these formulas, okay, but just to take you through the history of how did we come to know about the best good sources of protein scientifically. Okay, so DIAS score, we'll discuss the DIAS score in detail. Nowadays, we use the DIAS score to identify which is the best source of protein. DIAS stands for digestible indispensable amino acid score. On page number 82 onwards, DIAS is there. We'll take that later, but before that, we have to cover some topics. So you can see here which is the best source of protein, which is the poor source of protein. Okay, millets don't have much protein. Millets have other minerals, okay, like calcium, magnesium, phosphorus. They are rich in fiber, they are rich in minerals. They have some aspects which is quite high, which protein may not have, okay. But in terms of protein, they are very poor, millets, okay. Bread, we know that corn, rice, cooked peas, okay, barley. You can see the bad sources of protein. Chicken is a good source of protein. Chicken breast, okay, boneless chicken is a good source of protein. When you go for the chicken which has bones, you are increasing the fat content, okay. When you go for boneless meat or boneless chicken, that part of the chicken body does not have much fat, okay, that is protein rich. But when you have chicken leg piece or something like that, which the meat comes attached with a bone, okay, those pieces have high fat content as well. They are good sources of protein, no doubt, but your calorie will also increase because of fat content, okay. Only some of the daily used protein, vegetarian ones are given here, and non-vegetarian as well. So coming to biological assays, these are some formulas because of, a lot of tests were done, okay? Tests were done on animals, guinea pigs, mice, rats, rabbits, okay? On human, only fecal tests were done. On human beings, usually they do stool examination, fecal analysis, okay? Only that is done. But all the other form of test, major experiments were done on these animals, laboratory animals, and through which we come to a lot of formulations. We have come up with a lot of formulation. See, when it comes to fish, there are fatty fishes and there are low fat fishes. Okay. When you are having fish in the month of winters, generally you are having a high fat fish. Okay. Because ecology, according to ecology, the fishes that we catch during the winter months, they naturally have high fat content because high fat is what they produce to protect themselves from the cold. Okay. So in winters, when you have fish, usually even when it comes to sardines, okay, so mackerel sardines, there are different types of sardines, fatty sardines, not no fat sardines, okay, desi ones, okay. So when it comes to fishes, usually big fishes, they have high fat content. Small fishes, they have low fat content. But again, when it comes to small fishes, there are fatty fishes that you get in specific seasons. Okay, usually in the winter months, whatever fish you get is high in fat content. Okay, but the fish protein is a good source. It's one of the best source of proteins. Chickens with bones which are attached to bones, it's not about what is what contains in the bones, okay, it's the basic anatomy, okay. When any flesh part is attached to the bones, it definitely attaches itself to the bone fat, to the bones get attached to the uh, meat, and a lot of fat is present in that layer, okay. Other parts of the body, it's usually subcutaneous fat, that when you peel the when you skin the chicken, okay, that subcutaneous fat is lost. Big fish is also a healthy option of protein. Any fish is a healthy option of protein. So first is the biological value, okay. So biological value, is how you measure the protein that is absorbed in your body and retained, okay, and the protein that you have lost. Because if I give you 100 grams of eggs, your intestine will not absorb the complete 100 grams of eggs. Okay, maybe 75%, 80 gram is absorbed. Some part of the protein in the eggs will be lost, okay, because of undigested particles or something like that. Okay, or you had some fiber based food along with eggs, and the fiber did trap some of the protein, and because of which it was not absorbed. Okay, so biological value means the amount of nitrogen retained in the body, okay, divided by the amount of nitrogen absorbed multiplied by 100. So again, this formula was derived by doing some experiment on albino rats. Okay, a group of albino rats were given non-protein diet, and other group was given the diet which had protein, 10% protein for 10 days. And then the diet, urine, and feces of this albino rat groups were analyzed. Both the groups were analyzed. And out of which it was found that the albino rats which received 10% of protein, they had better growth, okay, and the albino rats which didn't receive any protein, they didn't had any growth. So this is an indicator that assume that the more nitrogen is retained when essential amino acids are present in sufficient amounts to meet the needs of growth. So when you do fecal analysis, you can understand how much, excuse me, how much nitrogen is retained in the body. In the feces, it is seen, okay, how much nitrogen, this much gram of protein was given, out of which this much gram was absorbed, it was retained, and how much came out in the feces. Then we have digestibility coefficient. Again, nitrogen absorbed divided by nitrogen intake multiplied by 100. 100 grams of protein was taken. When you do the fecal analysis, you know how much gram was absorbed, how much was went unabsorbed. Okay, so only the absorbed part will be in the numerator multiplied by 100. Net protein utilization. Very similar to other two formulas. In the numerator, nitrogen retained means the protein which was retained in the body, which was absorbed by the intestine, divided by total nitrogen which was given in form of protein. Okay, if you take 100 grams of any protein, automatically we know how much amount of nitrogen is present in that 100 grams of protein. Okay, atomic weight of nitrogen, how much is present in that 100 grams of protein. So intake of nitrogen, multiply the entire thing by 100. So net, that is a net protein utilization. Then protein efficiency ratio, PER, weight gain divided by protein intake in gram. Again, in this test also, two groups of albino rats were fed for 4 weeks on different kind of protein diets. Okay, and both the groups average weight gain was checked. Okay, and the weight gain, whatever the weight was there before the test and after the test, okay, subtract that, you will understand what is the weight gain. Okay, so the weight gain in one group of rat which was given good quality of protein, that comes on the numerator, and divided by 10% of the protein or whatever gram of protein was given to them, like controlled feeding was done for this rat. So whatever was the protein intake of these rats in gram, okay, so you will get the net protein efficiency ratio. So it completely depends on the weight gain. Then NDP, net dietary protein ratio. Protein, this depends on calories, okay? How much calories the protein is giving in the diet, only the protein, and total calories. For example, you are having rice, dal chawal, okay? Total calories would be a bowl of dal chawal, total calories would be around 200 kilocalories. But out of that, how much only protein is given? Protein could be giving hardly 50 calories or 40 calories, okay? So 50 or 40 will come in the numerator, 200 will come in the denominator because carbohydrates and fat present in the food, multiplied by NPU rate of that particular food, multiplied by 100. NPU rate, your NPU rates are done for different food, and the table is available online. If you want to check that, you can check, but it is usually not required, okay? These are only for laboratory practices. Net protein ratio, very similar to the test that was done on albino rat. Okay, weight gain on the test group minus the weight loss on the protein-free diet. Okay, two groups of rat were taken. In one group, a specific kind of protein was given to the rats. In the other group, no protein was given to the rat. Okay, so the rat group which received protein, definitely they will gain weight. The rat group which didn't receive any protein, definitely they will lose weight. They will lose the muscle mass, so the weight loss will be there. Okay. So the difference in the weight gain and the weight loss, how much ever weight was lost, how much ever weight was gained, okay, the difference in that will be the numerator divided by the protein consumed by this test group. Only the test group consumed protein, where the weight loss group didn't consume any protein. Okay. So the protein consumed by that one group multiplied by 100. So this is the net protein ratio. These experiments are not done on humans. It is only done on laboratory animals. Then we are coming to the scoring system. So all these biological assays which we have gone through right now, you don't have to mug up anything. I guess you have understood the concept of these assays, why it was used, just to identify which group of protein or which type of protein gives the maximum weight gain, which gives the least weight gain. Okay, to identify this, in which group of which specific kind of protein, when you have maximum nitrogen will be retained in the body, when which group of protein when you have, you will not get much nitrogen, majority of the nitrogen is lost from the body. To understand different food groups, different types of food, how the nitrogen is retained in different sources, how the protein helps in weight gain in different sources, to identify all these at a scientific level, these biological assays are used. Okay, for day-to-day use, these assays will not come into use. Okay, coming to scoring system. So first is the essential amino acid chemical score. Okay. So very easy. This score, we have three different scoring systems. Scoring system is done to see which protein is the best source of protein. Okay, which food is the best source of protein. The food group that gets the highest score is the best source of protein. Okay, to do comparison. Okay, and when you make this exchange list, okay, these scoring systems have helped the food exchange list as well. To compare two different sources of protein, okay, these scoring systems are used. So this amino acid score we do only to understand the chemical composition of protein. As I mentioned, there are certain protein sources which are complete. They have all the 10 essential amino acids. Some protein sources are incomplete. They have only few essential amino acids. Okay, so you take 100 gram of any test protein. Let's say you want to check soya protein. Okay, 100 gram of soybean. you took. Okay, you want to see the essential the essential amino acids that are present in soybean. Okay, so you put the put the mass of the essential amino acids as well. Okay, 100 gram of soybean, this many essential amino acids is present. Okay, that gram you will put here in the numerator. In denominator, gram of essential amino acids in 100 gram of reference pattern. Usually reference pattern is egg or milk. Okay, since egg and milk are the best source of amino acids, FAO and WHO, they will usually use egg and milk to compare all the other sources of protein. Okay, so in let's say 100 gram of egg, 100 gram of soy protein. In soy protein, how much ever essential amino acids is there, that becomes the numerator. In eggs, 100 gram of eggs, how much essential amino acids are there, that becomes the denominator, multiplied by 100. Okay, so different food will have different score. Okay, some will have more than one, some will have less than one. Okay, but finally you get the result. And the score has to be calculated for all the essential amino acids, and the lowest score will be taken. Whichever amino acid has the lowest score is called the limiting amino acid. Okay, which like the amino acid that does not comes up high, the amino acid which has the lowest score, we call that as a limiting amino acid, because this soy protein has A, B, C, D, X, like X, Y, Z, these many amino acids are present, but this specific amino acid is absent, or even if it is present, it is not showing up in human body. So that amino acid becomes the limiting amino acid, even though it may be present, but it is not utilized, or it is completely absent in soy protein. Okay, soy protein is also a good source of protein, but again, it lacks one or two essential amino acids. So whatever essential amino acids that is lacking in soy, that becomes the limiting amino acid. Okay, when the term limiting amino acid comes, you have to understand that amino acid is absent in this food source. Okay. Then we have the protein digestibility corrected amino acid score, PDCA. Both have very similar, PDCA and DIAS. Okay. DIAS is digestible indispensable amino acid score. PDCA is protein digestibility corrected amino acid score. Both have very similar formula. The only difference is that when you are checking the protein digestibility of a specific kind of food source, it is based, you have checked the digestibility based on the stool. Okay, whatever is the limiting amino acid. Okay, for example, stool sample was taken, a test protein was given to somebody. Okay, and let's say it was 100 gram of almond. Okay, 100 gram of almond was given to somebody, and uh, fecal matter was taken, stool sample was taken. Okay, and a limiting amino acid was found, the amino acid which was not absorbed by them. Okay, that was found in the stool. So that is a limiting amino acid in the test protein, and the same gram of amino acid in the reference protein becomes the denominator, usually egg or milk. Multiply by the protein digestibility, which is based on whatever is the content present in the stool. Okay, so in PDCAA, you are taking stool sample. Okay, but when we do DIAS score, we are not taking stool sample. You are taking the sample directly from the ileum. Okay, you are not waiting the sample to go through large intestine. Before the content of the stomach goes into the large intestine, whatever the content of the stomach reaches the ileum. Ileum is the last part of your small intestine. Duodenum, jejunum, ileum. Okay, anatomically speaking, duodenum is the first part of your small intestine. Jejunum is the middle part. Okay, ileum is the last part of the small intestine. Before the content of food goes into the large intestine from the small intestine, from the ileum, the samples are taken. Okay, content is taken from the ileum. other different Scopy methods are used for this. Okay. So from the ileum, when you get the content, that shows you, that gives you a better picture of how protein is actually digested within your body. Okay. The amino acid present in the content of ileum, the nitrogen present in the content of ileum, that gives you a better picture on how a protein is actually getting digested. Okay. Because when you take stool sample, a lot of nitrogen or other amino acids may still get absorbed in the intestine, which is very rare because intestine usually absorbs water and electrolytes and minerals, but some loss of nitrogen and amino acid you can expect through the large intestine. So it does not give you a better picture. But DIASCORE, it gives you the better picture of how exactly a protein is getting digested inside a human intestine. Okay, so that's the reason why now we usually use DIASCORE. So DIAS samples, they come from ileum, while PDCA samples come from the feces. Okay, if there are no amino acids in the feces sample, the PDCA method will assume complete digestion. For example, I give you 100 gram of almonds. Okay, almonds are also a good source of protein. So the feces sample which I take from you, it does not have any amino acids left. What I will think, okay, whatever protein was there in the almond, 100 gram of almond, your body completely used it. There is no wastage. Completely all the amino acids were taken up by the body from this 100 gram of almonds. Okay. But in DIAS sample, they will check the content of the ileum. Okay. Because it gives better accuracy. And from the ileum, when I take the sample, I give you 100 gram of almond. From your ileum, I'm taking the content and doing the test. I run the test and I understand some amino acids, undigested amino acids are present in the ileum content. Okay. Majority of the amino acids were absorbed, but some type of amino acids were not absorbed. It is still present in the ileum content. That gives me a better picture that actually these are the limiting amino acids in almond. Okay, limiting amino acids are the ones that the body rejects. The body does not absorb due to various other reasons. Okay, so is it clear to all what is the difference between PDCAA and DIASCORE? What actually happens in DIASCORE? How did we come with the with so many ranking system, scoring system? How these tests are actually done? So PDCAA is an easier method. It is not invasive, but DIASCORE is slightly invasive in nature. Okay. Coming to complementary value of protein. So this completely depends on incomplete proteins, which we have discussed earlier. They miss certain amino acids. Endoscopy is done usually. Endoscopy could be the one of the strategies used. Sigmoidoscopy, colonoscopy, endoscopy. Okay. So complementary value of protein. 2 or more incomplete protein sources, when eaten in combination or at the same meal during the same day, they compensate each other's lack of amino acids. Okay. For example, curd rice, whey protein, casein, it's not available in rice, right? It is only available in milk products, dairy products. Okay. And other forms of amino acids, essential, non-essential, if it is absent in the particular source of milk, because you are using curd, you are not using milk now. Okay. So curd rice is a good source of complete protein. Okay. Khichdi. Okay. You make khichdi out of dal and rice. Okay. The essential amino acids which are absent in rice are present in dal. Absent in dal are present in rice. When you cook them together or eat them together in the same meal, you're getting a complete protein. Okay. So usually when you mix grains with legumes like dal khichdi, okay, when you mix grains with seed, like when you make lemon rice, you use peanuts, or you use other pumpkin seeds, etc. Okay, any mixed rice that you make with some like poha, which you make. Okay, poha, in poha you put a lot of peanuts. Okay, you're using seeds complementing each other. And when you use make chutneys, okay, out of peanut chutney, coconut and peanut chutney, which you make for idli. Okay, idli is made up of grain and a legume. Urad dal is a legume. Okay, sorry, urad dal is a pulse. Grain is your rice. Okay, and you make chutney out of it, or a chutney out of the coconut and peanuts. You are using seeds. Okay, so when you have that complete breakfast, all the sources of protein, all the essential amino acids are met in that particular meal. Okay. Even kheer that you make, kheer using milk and rice, it's a complete source of protein. Paneer pulao, cheese sandwich, curd rice, pasta and cheese, idli, dosa, khichdi, chapati and chana. Okay. Coconut chutney with roasted Bengal gram dal. Okay. These are the examples given in the textbook. You can check that. So these are the complementary value of protein. Different type of food groups, they come together and they complement each other, okay, to make a complete source of protein. Presence of milk, not necessarily, because if you are lactose intolerant, it will reduce the intestinal absorption, but adding curd helps. Okay, majority of South Indians are lactose intolerant. If you see geographically, central below Maharashtra, and from Odisha onwards, Odisha, Maharashtra, Karnataka, Kerala, Tamil Nadu, Telangana, etc., Andhra Pradesh, etc. Majority of the South Indians are lactose intolerant, but North Indians are, they can tolerate milk more. Okay, it's because of the ethnicity. Majorly, South Indians are of a Dravidian ethnicity. So, and the North Indians, because of the Mongolian invasion. Okay, it was because of Mongolian invasion. Mongols had this mutation in which they were able to digest milk even after the children were breastfed. Okay, so they could use the Mongols were able, not the Mughals, Mongols. Okay, Mongolian region, the Genghis Khan Mongolian era. Okay, so they were able to adapt to the usage of milk even in later stages of their life because of this mutation, and because of Aryan invasion and different invasions that happened in northern parts of the Indian terrain. That's the reason why North Indians, majority of them, have the gene to digest milk. Okay, they have the gene that still produces lactase in their body. Okay, even after infancy, even after childhood. Okay, but that gene in majority of the South Indians, they lack. That's the reason why South Indians, they resort to curd rice. Okay, curd rice is a staple in South India, and also the fermented rice or curd based food. Okay, that is more common in South India. Milk based food is very rare in South India, but milk based sweets and milk based other food, paneer based food, okay, these are more common in northern parts of India. This is the reason why. Okay, genetically, South Indians can do better with uh, curd as compared to milk, but North Indians can do better with milk as well as curd. Okay. Requirements and RDA. Those who have the textbook, page 91. Requirements of infants. Okay, it is given in textbook. You can just go through it. No need to mug up anything. just go to the RDA table, table 5.11 on page number 91, protein requirement as per ICMR is given. In the new textbook, I don't know what is the table number. Please check and let me know. In the new textbook, it would be the ICMR 2022 recommendation, most probably. It's the 2023 recommendation. Page number 95. So please check the RDA. Those who have the old textbook, you can check online as well. ICMR 2023 recommendation. You will find the same information, okay? Coming to the sources of protein. Plant-based sources, we'll do that first. Soybean is the best plant-based source for vegetarians. Tempeh is also another kind of fermented soy product. It is newly launched. Okay, all the soy products. Groundnuts, sesame seeds, lentils, then your nuts, seeds, etc. For non-vegetarians, liver is the best source of protein, even as compared to meat or others. Liver, sheep liver, or any form of liver, organ meat is a good source of protein. Hilsa fish. Hilsa fish is a staple, it's a ethnically staple food for Bengalis. And you can check online as well, the recent best sources of protein. Sesame seeds, you can just sprinkle some sesame seeds when you make any sabzi. Okay, at the end, just sprinkle some sesame seeds and have. You can have til laddu. Okay. Sesame seeds is also a good source of calcium as well. Okay. Rice contains less protein than wheat, but the quality of protein in rice is better. Okay, because wheat has gluten. Okay, gluten is also a type of protein. Wheat has gluten, but gluten prevents the absorption. It is very sticky in nature. Okay, that because of that sticky nature of gluten, it can prevent the absorption of other proteins. Rice does not have gluten. Rice has less amount of protein as compared to wheat, but the quality is better because of the absence of gluten in rice. Okay. Roasted sesame seeds would be better. If you take more protein as like whatever more than recommended, excess amount of protein will be converted into fat and it will be stored in your body. Too much of protein will be converted into fat and it will be stored in the body. Okay, but this protein which has been converted into fat cannot ever convert back into protein. Once the protein is converted into fat inside your body, it will stay as a fat. You can never revert it back into protein. Okay. Too much of glucose is also converted into fat. You can never revert it back into glucose. Right? Glucose converted into glycogen can be reverted back into glucose because the body stores glucose in the form of glycogen as well. Okay. When the glycogen stores are also filled and the body still has glucose, that's when the glucose is converted into fat. When the protein stores are filled, but the body still has access of protein to deal with, that protein is converted into fat. Excess protein is bad for the body. It damages your kidney. it will be converted into fat, it will give you obesity, it will damage the kidney, because the excess protein will try their best to get out of the kidney filtration, get into the urine and get out of your body. In that loop, your kidney membranes get damaged. Yes, the uric acid increases in that same loop. Okay. Protein supplements come in so many different form other than whey protein. You have plant-based protein, pea protein, okay. You have lactose-free proteins present. Spirulina is that's a algae, another source of protein in form of tablets. It is present. Okay, there are different forms of protein. Protein supplementation. Why you will require? You require just 8 glasses of water regularly. Okay, but digestion of protein requires more energy. Okay, digestion of protein requires more energy. And when too much energy is required, the cells, they get exhausted out of hydrogen ions. So to rehydrate them, you require water. That's it. But it will not increase your thirst until and unless you are dehydrated. If your body is well hydrated, you're taking protein supplements, your water intake will not rise. Okay. You are giving your body enough water to aid in the digestion of protein. That's the reason why when you eat protein-rich diet, you lose weight, because to break down protein, to digest protein, a lot of energy is required. So your body is spending energy, spending calories just to digest protein. Okay. That is one of the way how you lose weight when you have a protein-rich diet. Yeah, protein is a thermic food.